Hi, calculus students. So we've had several questions about Riemann sums and going back and forth between integral notations. And so I just wanted to make a video to talk about this a little bit more and what I see when I look at summation notation and thinking about integration. So I know that if I'm doing Riemann sums, then I'm thinking about either Riemann sums, either rectangles or trapezoids. Typically, if you start with this summation notation, it's rectangles. So I'm thinking rectangles. And I know that rectangles have heights by width to find their area. So Riemann is a sum of areas. So we're summing rectangles and summing the area of each rectangle, and they have a height and a width. So if I think about a function, and if I'm wanting to estimate area using rectangles with this, well, I'm going to break it up into a bunch of smaller rectangles, and I'm going to use some sort of width that's consistent, and I'll go up to the height of the function and then make a rectangle and find that area. And then I'll do the same width length and go up to the height of the rectangle, up to the height of the function, and then make another rectangle. So if I'm taking my total width that I want to find the area of, so let's say this one I'm going from 0 to 5, then I'm going to break this up into n rectangles. So each rectangle, so my total width is 5, and each rectangle is going to be 5 over n, because I'm going to make n rectangles with an equal amount of width. And where I got that looking at this equation is seeing this bit here. So this bit that has no k in it is going to be the width of every rectangle. The 5 tells me the total width of the area. So I know I'm looking for an integral that has a distance from a to b. So I know that my b minus a has to equal 5 because that's my total width. So this is 5 over n is the width of each rectangle. 5 is your total width. So 1 to 6, 1 to 6, 0 to 5, 0 to 5. All of those could be possibilities. So now I need to dig deeper. All right, so if I think about what I'm doing to find the height of each rectangle, well, if this is my f of x, then this first height is going to be f of x1. So these are my heights. And then my second one is going to be f of x2, etc., etc. Well, x1 is going to be equal to my starting point plus the width. So let me just slide this up a little bit. Or not. Okay. That's unfortunate. Okay, so x1 is going to be my starting value, wherever it is. So maybe it's 0, maybe it's 1 from what I saw above. So I'm going to take the starting value, which of course is the bottom of my integral. So that's my a. And then I'm going to add one of my widths. So plus 1 width. The width is 5 over n, so plus 1, 5 over n. So my starting value is a plus 5 over n times 2. My third width will be the starting value plus 5 over n times 3, etc., etc., until finally my nth x value is going to be a plus 5 over n times, not x, times n. Well, of course, those n's are just going to cancel. I'll get a plus 5, which is my endpoint. So if I start at 0, I would end up at 5. If I started at 1, I would end up at 6. But that last x value is your b value. So we're going from a to b. Well, I don't want to have to write out every single x value, especially because n is going to go up to infinity. So that's why I need my summation notation. So I'm going to take the sum from k equals 1 to n, f of x sub k, so that's all my heights, times 5 over n, which is my widths. Well, f of x sub k, that was f of whatever the starting value was, plus different increments of the width. Each increment I can count using k. So sum of k equals 1 to n. This would be if I'm doing a right Riemann sum, because I started by taking the initial and adding 1k. If I was going to do a left Riemann sum, I would just start at 0, because then I would just start at f of a, which would be my first one here. So now I am looking for 5n times k. So coming back up here, well, it's pretty close that this is 5 over n times k, but there's another, that's 10, so that's really going to be 2 times 5k over n, square root of 1 plus 5k over n. And then these are making all of my heights. So I'm going to erase this for a moment. So those are my heights. And we said that we needed to start by seeing a plus 5n over k. Well, I might think that the a value is 1, but that doesn't happen here. So that must mean that my a value is 0, which now means that I'm only looking at C or D. And then I have 2 times each of these are taking the place of my x's. So each addition of 5k plus n is incrementing my x values. So I'm going to end up with a being 0, and I've got 2 times x root 1 plus x as my original function. So that's why it has to be this one. I hope that helped. As always, keep reaching out to us on the question document or via chat or requesting individual chats. We're happy to help you.